Our journey begins roughly 4.5 billion years ago with the formation of Earth. Imagine a swirling cloud of dust and gas, remnants of a supernova gradually coalescing under the force of gravity. This nascent planet, a hot and volatile sphere, bore little resemblance to the world we know today. Over millions of years, Earth cooled, the surface solidified, forming the first continents. Volcanoes erupted, spewing gases that would eventually form our atmosphere. Water vapor condensed, falling as torrential rains that filled the first oceans. These early oceans, warm and rich in dissolved minerals, would become the cradle of life. This period, known as the Hadean Eon, was a time of intense geological activity, a turbulent beginning that set the stage for life's emergence. Around 4 billion years ago, in the primordial soup of Earth's early oceans, something extraordinary happened. The building blocks of life, simple organic molecules, assembled into more complex structures. These structures, eventually capable of self-replication, marked the birth of the first life forms. The exact mechanisms by which life arose from non-living matter remain a subject of scientific inquiry. However, we know that these early life forms were single-celled organisms, similar to modern-day bacteria. They were simple yet remarkably resilient, able to survive and reproduce in Earth's harsh early environment. This period, the Archean Eon, spanned a vast stretch of time, from 4 billion to 2.5 billion years ago. Over these eons, single-celled life diversified, evolving new metabolic pathways and adapting to new environments. The next major leap in the evolution of life occurred around 2.5 billion years ago, the emergence of multicellular organisms. This transition from single cells to complex multicellular life was a pivotal event in Earth's history. Imagine single-celled organisms cooperating, forming colonies, and eventually specializing in different functions. This division of labor, with different cells performing different tasks, allowed for greater complexity and efficiency. The first multicellular organisms were simple, soft-bodied creatures. Over time, they evolved into a dazzling array of forms, from strange and wonderful creatures in the Ediacaran period to the ancestors of plants, fungi, and animals. Section 4, Life Explodes, the Cambrian Explosion and beyond. About 540 million years ago, life on Earth underwent a dramatic transformation known as the Cambrian Explosion. This event is one of the most significant in the history of our planet. In a relatively short period, a burst of evolutionary innovation occurred, resulting in the sudden appearance of most major animal groups. This rapid diversification is unparalleled in Earth's history. During this period, the oceans teemed with creatures of astonishing diversity. New forms of life emerged, each adapting to their unique environments. Trilobites, with their segmented bodies and hard exoskeletons, scuttled across the seafloor. They were among the most successful and diverse groups of early animals. Early fish, the first vertebrates, swam through the water. These pioneers of the vertebrate lineage would eventually give rise to all fish, amphibians, reptiles, birds, and mammals. The ancestors of insects, crustaceans, and countless other invertebrates evolved, filling every ecological niche. Their descendants continue to thrive in today's oceans and on land. The Cambrian Explosion marks a turning point in the history of life. It set the stage for the complex ecosystems we see today. It is a testament to the power of natural selection to drive rapid evolutionary change and to the incredible diversity that can arise from a common ancestor. The legacy of the Cambrian Explosion is still evident in the vast array of life forms that inhabit our planet. Section 5. From fins to feet. The rise of vertebrates. From the early fish of the Cambrian period, a new group of animals evolved, the vertebrates. These creatures, with their internal skeletons and backbones, possessed a unique advantage in terms of mobility and strength. Over millions of years, different groups of vertebrates evolved and diversified. Some, like sharks and rays, remained in the oceans, becoming formidable predators. Others, the first amphibians, ventured onto land, paving the way for the evolution of terrestrial vertebrates. The transition from water to land was a pivotal event in vertebrate evolution. It required adaptations for breathing air, moving on land, and resisting the pull of gravity. Section 6. A new era, the Age of Mammals. As the reign of the dinosaurs came to an end around 66 million years ago, a new era dawned, the age of mammals. This monumental shift was triggered by a catastrophic asteroid impact that wiped out the dominant reptilian giants, paving the way for mammals to flourish. These warm-blooded creatures, with their fur or hair and their ability to nurture their young with milk, were well suited to a variety of environments. Their adaptability allowed them to thrive in diverse habitats, from dense forests to open plains. Mammals diversified rapidly, evolving into a wide range of forms, from tiny shrews to giant whales. This incredible diversity enabled them to occupy ecological niches left vacant by the dinosaurs. Some took to the trees, giving rise to the primates. These early primates developed traits that would eventually lead to the evolution of humans. Others, like the ancestors of horses and deer, adapted to life on the open grasslands. These adaptations allowed them to exploit new food sources and avoid predators. This era, the Cenozoic, is often called the Age of Mammals due to their dominance in most terrestrial ecosystems. Mammals became the most prominent and diverse group of animals on land. This period witnessed the rise of many familiar mammal groups, including the lineage that eventually led to humans. The evolutionary journey of mammals during this era set the stage for the modern world we know today. Section 7, The Human Story, Our Place in the Grand Tapestry of Life. The story of human evolution is a long and complex one, spanning millions of years, filled with countless twists and turns. Our earliest ancestors, small ape-like creatures, evolved in Africa, adapting to the diverse and challenging environments. Over time, they developed bipedalism, the ability to walk upright on two legs, which was a significant evolutionary milestone. This freed their hands for tool use, a crucial development in human evolution, allowing them to manipulate their environment in new ways. As our ancestors evolved larger brains and more complex social structures, they developed language, art, and culture, which became the foundation of human society. Humans, with their capacity for abstract thought and innovation, became the dominant species on Earth, shaping the world in unprecedented ways. Our journey through the history of life highlights the interconnectedness of all living things, emphasizing our role within the broader ecosystem. We are a product of billions of years of evolution, shaped by the same forces that have shaped all life on Earth, from the simplest organisms to the most complex. Understanding evolution is not just about knowing our past, it is about understanding our present and shaping our future, ensuring we continue to thrive in harmony with the natural world.